or what?
Yes, sir. We panelists are only 6 or 7, sir. Because then they can hear us, they can see us, and also they can post their questions in the question answer box.
But they cannot ask us question live.
Live, no, sir. Because we have had generally we avoid that because there's a lot of confusion and commotion when that happens. So we kind of.
There is another link that they get or what?
No, sir. Right at the bottom of the screen, there is a Q&A box, so they can post.
No, I know Q&A. I know, but are they on another link or the same link?
Same link, sir, but their permissions are different.
Okay.
Naresh, shall we start?
Yes, Professor.
Is a couple of more minutes, or is it 6:30?
It's 2 minutes. 2 minutes.
Okay. So wait for. Yes, we have to wait for the IITM YouTube channel to start, right? So we should start. Okay. Welcome to the Self-Reliant India webinars by SIDDHI to commemorate the 74th Independence anniversary. Today is 14th August 2021, and today the speaker is Professor Ashok Jhunjhunwala, one of the topmost experts on energy, and also he is an institute professor at IIT Madras, president of IIT Madras Research Park, and IITM Incubation Cell and RTPI. And today he is going to talk about India's energy needs and innovative solutions. And Professor Jhunjhunwala is actually one of the biggest names in India's energy sector. He has been actually a principal advisor to many ministries in the government of India. And right from a pretty early age, he has been one of the most distinguished technologists who has not only worked in the institutions of research, but also translated his work into for social welfare as well. So he has been a very great supporter of Gandhian vision of technology in rural development, and to use technology in a way where we can have sustainable, equitable, and inclusive growth. Without further ado, I want to introduce SIDDHI a little bit. SIDDHI is actually a platform to create synergies between various stakeholders, especially take socially relevant technologies to the world outside. And we want to bring experts, industry, academia, government officials, policymakers, social entrepreneurs, think tanks, and the general public and NGOs. And just to add, Professor Jhunjhunwala has actually made it into a reality with IITM Research Park, what we have been ideating. And so he has kind of been 10 or 15 years ahead of us in terms of what we have been doing. He has already done it. So we are very proud and very honored to have Professor Jhunjhunwala amongst us. And I hand over the microphone to Professor Raghunathan Rangaswamy, Dean of Global Engagement, IIT Madras, to introduce Professor Jhunjhunwala and take the talk forward. Thank you very much.
You don't need to introduce me. You have done enough.
No, Ashok, I'll just a couple of words. Ashok, Professor Jhunjhunwala, as you know, is the president of IIT Madras Research Park, and he's been a faculty who's really pushed IIT Madras faculty, in fact, to start thinking about commercialization. And I've had discussions with him. Anytime I go and we discuss the science, after the science, he will say, will it work? What will be the cost? So immediately there is this notion of whether this technology can be implemented and so on. So that's a wonderful thing for, in fact, faculty members to go talk to them and so on. And as he mentioned, I think there are several awards, and Sudarshan has done a good job of introducing him already. I just want to mention that he's been conferred with Padma Shri. And also another thing that does not seem to be here is he is also a foreign fellow of NAE, National Academy of Engineering in the US, which is a very, very prestigious award. So without saying anything much more, I'll request Professor Jhunjhunwala to deliver his talk. Thanks.
Thank you very much. Can I share screen?
Yes, please.
So I'm sharing my screen, and I hope you are able to see my PPT. And once you are able to see, I will just move
Yes,
ahead.
sir. Yes, sir.
Okay. My talk is something which I consider important for India. Basically, I've titled some steps for India to move towards 100% renewable energy. And let me point out what is the importance, what is the current state, what are the issues, and how do you go about doing this. And this is something that we are very serious that we want to do it. We are not talking theory, we are talking about what can be done, should be done, is being done, must be done. So the first, to give you a little background, in terms of there is a huge threat of global warming. Today it is well known. I don't have to talk about this audience, and most people are talking about it. And it comes because of our using fossil fuels, increasing use, coal, petrol, diesel, oil, LPG, natural gas, and all that. Now, the question comes, what should India do about this global warming? It impacts us probably more than other countries, but because with a large population, very dense population, it is going to impact us badly. But if you look at in terms of per capita carbon dioxide emission, we are not causing that emission per capita. If you look at it, it is per capita, it is Australia, United States, China, United Kingdom, most of Europe. India is 103rd in terms of per capita carbon dioxide emission. And our electricity consumption is also very low. It is 142nd in per capita electricity consumption. So what we will say that, well, yes, global warming is something that is caused by people all over the world. But you see, we consume so little per capita. We are a country which is going to develop. So don't stop us. Let us continue to develop. The onus of reversing the global warming should lie with those countries which are much higher consumption. So this could be one stand. To some extent, our government takes that stand in international forum, and to some extent it is right. But look at another aspect. Look at the data in a slightly different manner. In terms of total greenhouse emission, we rank third. China, of course, is the biggest polluter. Then comes United States, and then comes India. And basically, in terms of total, because we have large population, per capita is low. You multiply it by 1.35 billion, and it shows that we are a huge energy consumption, huge greenhouse gas emitter. So we are hurting the world as much as others are hurting. And since our GDP is just starting to grow, resulting into higher incomes, India's energy consumption is likely to continue to grow, and our greenhouse emissions are going to grow. So the GHG emissions has already increased by 335%, 3.35 times in 1990, and it's going on increasing. For example, air conditioning, which is one of the cause of this, we have only 8% of our homes have air conditioning. But as our incomes grow, more and more people will buy air conditioners. And we are expected to get to 50% by 2050. So we today may be third, very soon we will be second, and probably will be close to China, and we will become the biggest polluter. Therefore, we like it or not, the onus falls equally on us as on other countries. So while we need to continue to develop, we need to worry about greenhouse emission. Now, how does one go about doing it? This is a big question, because today, if you look at it, our energy consumption is primarily coal. 44% is coal, then crude oil, a little bit of natural gas, and electricity, which is also largely coming from coal. We use a little bit of, we use for transport, petrol and diesel. For cooking, we use LPG gas. So we are consuming more and more fossil fuel, and this is going to increase. How do we go about therefore reversing things? Let's look at the other thing. In terms of what do we have? We have, of course, solar and wind in India. And what is the status of solar and wind in India? So, for example, solar-based electricity costs only 2 rupees to 2 rupee 50 paise per kilowatt hour to generate. Wind cost around 2 rupee 50 paise. These numbers are equal or less than the cost of coal energy. Coal energy starts at 2 rupee 50, but goes up to 4 rupees depending on the age of the plant and the kind of emission control equipment that we used. And oil and gas costs even higher. 16 rupees was older number. Today it will be more like 22 rupees per kilowatt hour from oil, and from gas it will be 14-15 rupees. So one will say, why not switch to solar and wind? A natural question will arise, do we have enough solar and wind? In fact, we have more than enough. I had done a computation. There are a very small part of desert in Rajasthan can generate enough solar energy to meet not just today's needs, but over next 10 years needs of the country. And of course, we have wind, not just in the on the coast, but also we have ocean wind. We have not even started tapping it. So frankly speaking, India has enough solar and wind to meet its needs today's and tomorrow. Then where is the problem? The problem is solar and wind is not available 24/7. It is not controllable. Whereas coal is controllable. Coal I can turn on, turn off. Solar and wind is available as and when required. Now, since the consumption may not take place exactly when the solar and wind is generated, we need what is called energy storage. Energy storage. We need to store the energy and use it whenever we need. So therefore, there has to be a major focus on technology for energy storage. Now, our installed capacity of solar and wind renewable energy is 25%. Really boast about it. So we have already got 25%. But this is a very deceiving number. This is true, correct number. The total in terms of energy energy capacity, yes, solar and wind amounts to 25% and coal amounts to around 55%. But you know, solar and wind does not give you electricity all the time. And capacity utilization factor can be only 22%. Sun probably 16 to 18%, wind probably around 25%. So only 22% of the time solar and wind can give us the energy. And whereas coal gives us an energy at 85%. As a result of it, our total electricity generated from solar and wind is only about 8%. And it is dominated by coal. A little bit of hydro, a little bit of nuclear, some amount of natural gas, but very little of renewable energy, only 8%. Now, what is the problem? Basically, as I pointed out, the electricity, whatever is generated, needs to be consumed instantly. You need to meet the generation and the demand at every instant, every second you need to do this. Of course, how do we go about doing it? In the yesteryears, 10 years back, we used to do power cuts because we had a deficit of energy. So in some area or other, you will have power cuts and the energy generated will be only so much, and you will be able to meet the all the energy generated was consumed. Now, for if there are plants like oil and gas, and to some extent with coal, we can control them. So if there is a excessive energy generation, we can reduce it. If there is less energy generation, we can increase it. We can also do what is called demand management. We can incentivize consumers to sort of say not use electricity at some peak hours and use it during off-peak hours, which basically means postpone use of power when there is a surplus. That makes some difference, but not very significant difference. Of course, the fourth technique is we take the electricity, convert it in some other form, store it, and then get back the electricity when we need it and use it. What are the methods of storage? One can store the energy in terms of pumped water. For example, in a hydro plant, instead of generating electricity from falling water, we can pump the water back up to the top. And then whenever required, we can generate that. This has about 30 to 35% losses. One can think of generating and storing energy in flywheels, rotating flywheels. You generate it, put it into vacuum, and they keep on running. Question is, how long can we store? A day, 2 days, maximum. A third technique is, can we convert it to hydrogen and then reconvert to electricity? A lot of talks go on. But when you will see the numbers, you will see the cost of doing this today is huge. While we are talking about 2 rupees for generation of electricity, storing per kilowatt hour, storing 1 kilowatt hour of hydrogen and then reconverting to electricity, effective cost will be close to 80 to 100 rupees, 70 rupees. The fourth technique is store it in batteries. In lead acid battery yesterday, today we started using lithium-ion battery. We are doing it in laptops. We are doing it in cell phones. We can store large amount of energy. Tomorrow there can be solid state batteries, other batteries. This is very rapidly becoming dominant. So my talk is going to be quite a bit about this storage. Essentially, what do? We take the electricity from the grid and we use a bidirectional converter. We convert this AC electricity into DC because all the batteries only take DC electricity to store. Store it in the battery, convert it back to AC, and then use it. We use it with UPS at homes and offices. Inverters, what we call it. Essentially, this is the technique. Now we are talking about large energy storage to use it on demand. So we not only have to pay for the batteries, but we also have to pay for all the converters. That's what we really need to do. So the question is, how much will a storage cost? Let's take the best storage that we have, lithium-ion batteries. How much will it cost? Now, if I buy a battery, I have to buy, let's say, a megawatt hour or 1,000 kilowatt hour of a battery. There will be a certain amount of capital cost. It will cost me so much amount. Then question will come, how many times can I use it? Charge, discharge, charge, discharge. Ultimately, will the battery last forever or it will last for a finite amount of time? Actually, all the batteries last for a certain number of cycles. Remember, as you start using your cell phone, in 2 to 3 years' time, maybe 4 years' time, the battery becomes useless. Same thing happened with laptop. Actually, all batteries have this. They actually have a finite lifetime. So we need to figure out this battery that I purchased, what is the life cycles of the battery? And then what is the operation cost? Fortunately, operation cost is low. And then we'll ask question, how many times are you going to charge, discharge per day? Are you going to charge only once per day from solar and then use it in the evenings and the nights? Or are you going to charge with solar and then with wind and use it maybe 2 times a day, maybe 3 times a day? one will say, why does it make a difference? We'll show you it makes a difference. Will we charge it on the average 1.5 times a day? That means 1.5 cycle a day. If, for example, the life of the battery is 3,000 cycles, or sorry, 1,000 cycles, and I use it only once a day, it will last me for 3 years. If I use it 2 cycles a day, then it will last me only 1.5 years. What we will show you that while the capital cost is same, the interest cost will change, and that will impact the effective cost per kilowatt hours considerably, and we will have to worry about it. Then, is there a decay in the battery? Fortunately, these lithium-ion batteries, etc., do not decay. For several days, their decay will be hardly 1%. And what is the end-to-end energy efficiency, including the converters and any losses? We are able to get 95, 96, even 97%. So energy efficiency is also fairly good. And from there, we will have to, say, if I store 1 kilowatt hour and take out 1 kilowatt hour, what is my effective cost? Actually, I have to take all this into account, and I have to take what is called depreciation on my capital. I have to take the interest cost of my capital, and then compute the effective cost per kilowatt hour. Of course, on top of it, there are environmental costs, toxicity, hazardous, recyclability, and this is very, very important. Fortunately, we have learned that lithium-ion battery we can recycle almost completely with very little environmental impact. But this has to be always examined, because this can be one thing India can do wrong, and it will lead to a disaster. So let me, with this background, get into the actual numbers. Let us, for example, assume that solar and wind is generated whenever sun and wind is available. And let's assume 70% of the time we are able to use it immediately. So we don't store 70% of energy. That cost will be, let's say, average of ₹2.50 per kilowatt. 30% of energy, we put it into the storage and take it out of whenever we need it. And let the effective cost of storing 1 kilowatt hour of energy and using it be 1 Vs, a number S. And ₹2.50 is the generation cost, S is the storage cost. So my effective cost of electricity of 1 kilowatt hour of generating, storing, and then reusing it later is ₹2.50 plus S. Now, for 70% of the time, it is ₹2.50. 30% time, it is ₹2.50 plus S. So what is the average cost? Average cost works out to be ₹2.50 plus 0.3 times S. Now, if I only consumed 50% of electricity immediately and 50% I had to store, this number would have changed to ₹2.50 plus 0.5 S. I'm going to show you the impact of this. And let us talk about today and not tomorrow. What are the batteries that are available? I'm taking batteries which are available in my lab, the cells which are available. And I will use all the innovation to design and develop a very cost-effective battery. And I will also take into account the grid connect cost, the converter cost. And if I do this, I have two possibilities. There is a cell A, which is an advanced NMC cell, lithium-ion battery, which is cost me around 20,000 rupees per kilowatt hour, including the cost of converter and the battery, but it will last me about 7,000 cycles. And there is a cell B, LTO, which lasts 40,000 cycles, but the cost is 15,000 rupees. Let us take these two cells and see what happens. This, if I use it 1 cycle per day. So for example, if I use it for 20,000 cycles, it basically means I'll use it for large number of years. Sorry, if I have 20,000 cycles, I'll use it for large number of years. If I use it 2 or 3 cycles, I'll use it for slightly less number of years. Now, this is the effective cost of 1 kilowatt hour of storage, which I can charge and discharge for the life. And what is 1 kilowatt hour storage cost? If I take cell A, which is advanced NMC, and this is for the LTO. So the cost depends very, very drastically on the interest rate. If I take the interest rate of 2%, which is the interest rate that is in Europe, my cost is 3 to 4 rupees, 350 to 4 rupees per kilowatt. But if I take the interest rate 10% or more, which is prevalent in India, the cost of the lithium-ion battery works out to be close to 7 rupees per kilowatt. And cost of LTO batteries works out to be 11 rupees. Why? LTO batteries has a large initial cost. It lasts longer time, but my interest cost itself will kill it. Whereas NMC battery, it will be a slightly lower cost, more like 7 rupees per kilowatt hour. This is if I use 1 cycle per day. What if I use 2 cycles per day? Well, my cost comes down. This 3 to 4 rupees come to closer to 3 rupees 50 paise at 2%. It will be nearly same at 0 interest cost. But at our interest rate at 10%, the cost for lithium-ion battery comes down to 4 rupees 75 paise per kilowatt hour. Quite good. Whereas LTO battery is still about 7 rupees. Now I can use between 1 to 2 cycles. I can, on the average, do close to 2 cycles, and my costs can become closer to not 7 rupees, but more like 550 or 6 rupees or 550, 6 rupees. Now, this is what I will use and show what is doable. So as I told you, 1 cycle per day is 7 rupees, 2 cycles per day is 4 rupees 75%. In the West, as I told you, it is only 4 rupees per unit. Now, the bad part, we are talking about self-reliance and all that. But you know, country very often, or DISCOM very often decides to use LTO. Even though its cost is going to be very, very large. Why? Because the Europeans and Americans and Japanese will come and say, see, LTO is better. No, LTO is better if your interest cost is low. India does not pay small interest cost. It pays 10%, 12%. We don't even think that much Indian. We just blindly borrow things from the West. And many projects are using LTO or other things rather than using the right battery and designing it in the most cost-effective manner. I will say we will use this, and let's see what works out. So with that, if I take 70% energy directly used and 30% through storage, my cost is 2 rupees 50 plus 0.3s, which will work out to be 4 rupees 60 paise for 1 cycle and 4 rupees for the 2 cycles. So not bad. My effective average cost, if I put 30% storage, it is around 4 rupee 25 paise, 4 rupee 50 paise. This is with storage average cost. And of course, if this 30% becomes 50%, it will be higher. Now, besides the lithium-ion storage, there is another storage. This is a storage, you know, in India, large buildings, 40% of energy is used in air conditioning. And very often use what is called HVAC. HVAC system chills the water at 6 degrees centigrade and then circulate this water in pipes to every office and every room. And there it cools the air, and the air is then circulated in the room. What if we chill the water ahead of time and put it into an insulated storage tank and then use the water later on? Effectively, we are using electricity when surplus is available and using it when there is a deficit. It's a storage. This cost is much, much less. And I will in a minute start talking about IIT Madras Research Park, and we have a chilled water storage of 300 meter cube, and which is effectively 17,470 megajoules, and with a COP of 2 we have a 2.5 megawatt hour such storage. Remember that this storage costs me much less than lithium-ion storage. Okay, so with this background, let me talk about, therefore, what can India do today? What is the total cost of renewable energy then? If I use 30% immediately and rest through the storage, my effective cost is 4.25 rupee or something like this. If I use 50% through directly and 50% through storage, my cost does go up. It will come to closer to 550 or something like that. But we don't have to do it today. We start using 30% today, and by the time we build enough storage and are able to use 50%, the cost of batteries are falling very rapidly. The cost of batteries will come down. And I don't think we will get more than 4 rupees per kilowatt hour with storage on average. So we don't have to worry about more than 30% today. Let's start where we are. So the question is, where do we start? Now one can say, well, why doesn't all the generating station, the government build all these storage? Remember, the storage are very expensive and they are in their infancy. And unfortunately, they will land up listening to the white men and they're choosing LTO batteries. And India does not have that bigger amount of money. And it will happen slowly. Some pilot projects will happen. India will not move to renewable energy fast. So what is the best way to do it? Let us go to people who can afford and who will take it up. For example, take a place like IIT Madras Research Park. This is a picture of IIT Madras Research Park. This is a 1.2 million square feet area. It consumes 25 megawatt hour of electricity today, and once it is full, it will be consuming 40 to 45 megawatt hour every day. Can we do? And we are not short of funds. There are 40,000 commercial and office complexes in the country today. Most of them come in the upper income bracket and therefore are not short of funds. Can they do something? Today, we pay average cost of 11 rupees per kilowatt hour for the electricity. We actually pay close to 10 rupees, 9 rupees 75 paise for the electricity, including demand charges, close to 2 rupees per unit. Plus, we pay for diesel because whenever power goes off, we turn on a diesel generator. So the average cost comes out to be 11 rupees per unit. So what can we do? Can we do here? Can we use rooftop solar? Fortunately, rooftop solar costs very little, only 3 rupees per unit. And we are already using it. But we can only generate 10%, 12% of the energy on the rooftop. We cannot generate more because rooftop space is not more. So what more can we do? It is here we found out that India has an open access policy, which basically means that if I generate solar and wind anywhere, I can wheel that energy through the power transmission and distribution network that exists and pay them for wheeling the electricity. There is an open access policy by which I don't even have to do it on my own. A group of us can go together and set up a solar and wind energy and wheel it to the complex. I can wheel it to the research park. Now that cost is higher. It is because there is a third party doing it. Size is not gigawatt hour, it's smaller. Its cost is around 3 rupees 60 paise per kilowatt hour. So let's say I paid this. My transmission and wheeling cost, including the distribution cost, is 90 paise per kilowatt hour. Plus, I pay demand charges. Demand charges that I pay in research park today is 2 rupees per kilowatt hour. And I will land up paying that unless I can really manage the energy very well. And if I manage the energy very well, my payment will be around 1 rupee per kilowatt hour. So my average cost that I will pay for getting completely renewable energy onto the complex is 360 plus 90 paise is 450 plus 1, 5 rupee 50 paise per kilowatt hour. Now, however, the problem is that solar and wind will be generated whenever it is generated. Then if I cannot use it all of the time, I'll have to store it. And therefore, I need energy storage. And therefore, at IIT Madras Research Park, as a part of IOE project and as a part of that IIT Madras has taken, and as a part of the IIT Madras Research Park own initiative to move towards 100% renewable energy, we are in the process of building 10 plus, probably closer to 20 megawatt hour lithium ion plus chilled water storage. And we can do it at each office complex. And we can, of course, look at all other forms of storage. And we will do a very, very good energy management. That's a critical, because otherwise this cost will go to 2 rupees per kilowatt hour. If we do that, what happens? Well, as I told you, if 70% energy I will use directly and 30% through storage, my cost will be 2 rupee 10 paise per kilowatt hour. That's my cost of storage. Plus, as I just calculated, it will be 5 rupee 50 paise for generation in group captive mode, transmission, wheeling and distribution, plus demand charges. So if I add this up, my cost is close to 7 rupees 60 paise. Maybe I add a little bit, 8 rupees per unit. Remember, I'm paying 11 rupees per unit today. So if I do this, not only I become all green, not only India uses more renewable energy, I actually save money. Even though I'm paying 2 rupees, close to 2 rupees or more to the discount. And I'm paying higher for generation. So this is a very, very good prospect. And it's a huge prospect. Of course, R&D takes a different kind of money. My prototype cost may be higher, but once we build it in large amount, this is the kind of cost that we are talking about. And there are 40,000 such complex. Every complex can do this. Once we do this, we move significantly towards renewable energy. And this is the beginning. We can first do it in office complex and commercial complex. Then we do it in all government building, institutes, colleges, and all other things. Then we move with a similar thing to the industry. By that time, the storage cost would have come down and all these costs would have come down. And the industry will benefit and the industry will adopt it. And then large urban housing complex. All of these can afford to pay. By the time we do this, we are 60 to 70% of our country's renewable energy. That instead of depending on government, depending on generation station and discoms, which are all bankrupt to do it, let us do from the upper end. This is the story that I'm actually telling. Financials will improve over time. Captive energy, instead of costing 3 rupee 50, will cost about 2 rupees 75 paise. Transmission and wheeling and distribution will go down below 2 rupees, probably 1 rupee 50 paise. And storage cost will also fall down, even with 50% of energy. So I have no problem tomorrow with 50% energy. And my cost will be around 6 rupees to 6.50. It's a huge gain. All the housing complex, industry, schools, colleges, everybody can do it. We can brand ourselves as 24/7 renewable. We can eliminate diesel generator and storage will pay us back in a few years' time. Now, what if we do it all over India? First, let's go back and look a little bit at the generation. What about when is solar generated and when is wind generated? Now, this is the average energy generated in a day. Solar kind of peaks around 12 o'clock, 1 o'clock, and then goes down in the evenings and is not there till 6 a.m. Wind, on the other hand, is there and it's significantly there in the evening. So, we will get solar and wind if we are there. And the question is what should be the size of solar and wind? Actually, this is a simple exercise that we can do. We can take the average generation we can take the high generation and low generation, and we can learn to compute the storage and short-term storage. These are short-term storage. The battery storage and chilled water storage can last for 1 or 2 days. We cannot use it as a long-term storage. And we can compute it, and we have done the computation. And for research park, we can actually do it quite easily at 15 megawatt hour or so. But what about long-term? Unfortunately, even the solar generation is pretty uniform in India throughout the year, with some dips around January, some dip during the monsoon period. Wind is very, very different. Wind peaks for about 4 months, is all right for the next 2 months, and then really dips over the rest of the months. Now, if we are going to use wind quite a bit, we need to do long-term storage. And long-term storage, batteries are not good for that long-term storage. And that's where we really need to look for alternatives. Can we use pumped hydro? Well, that's where R&D is required. Can we use compressed air storage? Someday, maybe R&D is required. Can I use hydrogen storage? As I told you today, the cost is very, very. Remember, we got 7 to 8 rupees for lithium-ion battery. For hydrogen is 80 rupees. But tomorrow, the cost will come down. Lithium-ion batteries are not storage. It's not suitable. Are there other batteries suitable? We'll look at it. This is what we need to do as far as the generation is concerned and storage is concerned. But where do we use it? We actually use a considerable amount of energy in transport. We use it in cooking. Cooking can switch over to solar, where I'll talk about it in a short while. Industry has to use it. Let's start looking at what all we need to do. For example, another major thrust that we need to do is electric vehicles. Auto sector is the biggest polluter in the country, and we are 14 of the 20 most polluted cities in the country is in India. And we are very, very heavy importer of oil in India, very heavy importer. If you switch to electric vehicle is 4 times more energy efficient. We have about 90% efficiency as opposed to ICE engine, which is 22 to 23%. And we can have very few moving parts. So as a result, these vehicles last much longer, and there is no oil dependence. So it's the right thing to do. Where is the problem? Well, India, for example, the biggest problem is affordability. We use two-wheelers. 80% of our vehicles are two-wheelers, 5% are three-wheelers. So 85% are two-wheelers and three-wheelers. And remember, our two-wheelers are 50,000 rupees, 60,000 rupees. Unlike West or other places, where we start at $2,000. So in India, it is a huge issue. How do you make low-cost electric vehicles? But our prime consumption is in two-wheelers, three-wheelers, and what is called low cost, less than 10 lakh rupees, 1 million car. If we focus on them and make them affordable, then India can win. So one of the things that we in India is of huge importance is what's called battery swapping. Now, battery swapping is like LPG gas cylinder swapping. Whenever we run out of gas cylinder, we get another cylinder. Battery swapping is a similar, you don't purchase a battery. If you don't purchase a battery, then the cost of electric vehicle is very low. In fact, much less than the petrol vehicle. And you take the battery on demand. You rent the battery, use it, and as soon as you empty it, give it back and take another battery. This can be done in 2 to 4 minutes. There can be outlets, maybe every street corner or maybe every few kilometers, and we can then, instead of filling petrol, we can actually do this. It's actually very beneficial for batteries. Batteries will not have to be charged. Our temperatures are very high, 45 degrees centigrade. It kills the batteries. So now, if you're swapping battery, we can charge the battery at cool the battery and charge it. Give me a second. Bhavani, please. So this will increase the life of the battery like anything. So this is extremely useful. The next question that is asked about electric vehicle is that, is this going to threaten our GDP? Because our 12% of GDP depends on the auto sector today. 7% on auto sector, 5% on fuel refining, distribution, etc. Are we going to hurt our GDP? Now, what do the electric vehicles require? They require battery materials. And as I pointed out, we can actually recycle lithium-ion batteries and get 90% of our material back. That cost is going to be very low. Battery cell can be manufactured in India. Packs, motors and controllers, chargers, and vehicle controllers and converters, all of them have to be designed in India and manufactured in India. If they are all done in India, the contribution to GDP will be higher than 12%. If you are, of course, going to import it from China and elsewhere, we are going to hurt our GDP. So one of the biggest tasks is, how do you design and develop all these things? And this is one of the other things that we are doing at the research park, full-fledged design and develop all this. We have looked into each and everything. What does lithium-ion battery materials cost? 35% value. How do you recycle it? How do you design cells? We are not going to be able to design cells. That's not our expertise. But there is a PLI, the production link incentive, that we have pushed in the policy, and Niti Aayog and DHI has come with this, and hopefully we'll get the manufacturing done in India. Pack design is very, very much required in India, because India's thermal temperature goes 45, 48 degrees centigrade. Most batteries are not designed for that. We need a very, very careful design, and we are doing it. And similarly, every motor and controller, we are doing this. And we are determined to make India work in this manner. I'll move to yet another topic, where we have been doing work for last 8-9 years, a solar DC concept, which we are trying to use solar electricity, but we are using it in home. And our first focus is to use it in villages and even in those areas where there is no grid electricity. And we have been on it for the last 8 to 9 years and have done very well. I'll tell you a story. I live on IIT campus, and December of 2015, almost 6 years back now, there was a flooding, and such flooding, there was a huge storm, flooding, huge rain, and there was no power in whole of Chennai city for about 75 hours. In fact, so much so that even the cell towers did not have power. So all the telephones also had stopped working. Much of the city was flooded. Even the solar plants stopped producing electricity, because solar plants are designed, if there is electricity being produced, it adds to the electricity. If it is not, it cannot match supply and demand. So solar power plant cannot be used. So even the solar plants were all shut down. So they were full darkness. And in that time, one home at IIT campus, happened to be my home, continued to have electricity, and my lights, fans, my cell phone charger, laptop charger, everything was working. How? I had a very smart solar panel on the rooftop, 125 watt, and only half a kilowatt hour of battery. But I had tube lights, bulb, fan, laptop, and cell phone chargers in my home. And that was giving me electricity. How did it do? It lasted for 4 hours, 75 hours. How did it provide me? It never went off. I was worried that it will go off, but my home had the electricity. The key thing was what is called solar DC inverters, where I had done in my home full DC wiring. All loads were DC. Solar and battery were connected on DC line. Input grid power was converted to DC. Of course, input grid was off. That was no problem. My home continued to function. Let me talk very briefly about this technology, because this technology is important. This debate, should we have AC electricity or DC electricity? There was a huge debate in 1880s when the electricity was just coming in. Thomas Edison wanted, the inventor of the bulb wanted DC. Tesla wanted AC. And there was a huge battle for several years. Finally, AC could be transmitted because one could come up with a transformer and upconvert AC to very high voltage, in which case transmission loss became less. It was high voltage, low current, and the losses are I square R, and therefore AC won and the DC electricity faded. And no R&D went on after 1880s into DC. Then AC became transmission lines, our home, offices, all appliances became AC, all R&D took place on AC. So why are we talking on DC? We are talking on DC because 8 years back when we started, by the way, my area was telecommunication. I am the one person who had worked on wireless in local loop along with Bhaskar Ramurthy and Timothy Gonzalez. And that was what we had done from 1990s and early part of 2000. My work in solar started only about 8 or 9 years back. When we started working on solar was very expensive and it was not making any sense. And that's a time I sat down and learned. I did not even know that solar panels produces DC power and not AC power. And what do? We convert DC to AC. Because our grid is AC, so we will convert it to AC and match it with AC. Well, fine. I also did the same. Then I wanted to store it in a battery, because if there was no grid, I could use the battery. But battery also uses only DC. So both the grid power as well as my solar power, the combined power I converted into DC and stored in the battery. And then whenever I needed it, I took the battery power out, DC, and then I converted it to AC. And then I fed to the AC load. Of course, if I didn't pass it through the electricity, I could put it directly to the AC load. But when I went through this, which I was going to do for most of the time, evenings, nights, whenever solar was not there and grid was not there most of the time, then I needed to do it with battery. Actually, I found that I'm using 3 converters, DC to AC, AC to DC, DC to AC. The converters, and we designed good converters. And I had a very small solar, 125 watts. So very low power converters. And still there was about 15% losses in each of the converter. And I suddenly figured out that this is what was being designed in India and used. And there are 45 to 50% losses. I have such valuable solar energy and I am going through 50% losses, 45 to 50% losses. It made no sense at all. And I thought, what do I do? And then I also realized that it gets worse. It gets worse because by that time, LED tube lights and bulbs were coming. And LED uses only DC. So my load was also DC. So I was taking this AC and I was converting it back to DC. Here also I was wasting about 10 to 15% energy. And then with a friend of mine, a colleague of mine, a faculty, told me that you can actually use brushless DC motors for the fans. And we built a brushless DC motor fan. And instead of consuming 72 watts for the fan that you use it at your home, we are able to do the same speed fan at 30 watts because brushless DC motors are much more efficient. But then we use a DC electricity. So our consumption also goes down if I use DC. And but I have to do now AC to DC converter. Not just this, my television and all electronics used only DC. My cell phone, laptop, everything used DC. Even we thought that refrigerator, air conditioner, washing machine essentially are motors, and I can use DC motors and SR motors, and I can bring down the power consumption by 50%. But then I need DC power. Why use AC power? And that's a time we came up with what's called a solar DC system. Solar DC directly, you convert grid into DC and store DC power back into the battery directly, take it out as a DC power and directly do it and feed the load. And we said we'll use 48 volt because 12 and 24 volt will double and quadruple the current. I square R is the losses will become very high. So we built this whole thing. My losses came to much, much less. My primary loss was in AC, which AC losses didn't matter. Solar was expensive, and I needed a little bit of DC-DC converter, but not. There was a complex design. Design was actually very complex. It took us almost a year and a half to perfect the design, but finally we were actually able to do this design. Once we designed this, I started using it. First, I used it in my office. Many of my colleagues used to walk by my office and just run by my office, trying to look inside the office and run it, as if they have seen a booth, a demon. After some time, they will come into my office and say, it looks like your room, there is no change. AC and DC. I said, well, I've designed this DC bulbs, DC tube lights, DC fans, DC plug points, exactly like AC. Why will there be change? But they were initially telling me you will take the country back. This is the biggest obstacle we found. But we did this and we designed it and commercialized the system. We incubated a company at IIT Madras and started designing this 125 watt system, initially with lead acid battery. Later on, we did a lithium ion battery, and we will do up to 500 watts, and we'll feed the home, DC power the homes. I first did my office, then I did our director, Bhaskar Ramurthy, was not director at that time, his office, my office rooms. Once I did this, I first powered my home. And that's a story that I have told you in 1995. Actually, I had done this only 6 months before that, about a year before that. And then I started commercializing and using it. We built a LED bulb, which was consuming only 5 watts instead of 30 watts. We designed a charger and socket. And we designed a charger and socket, different kind, so that you don't confuse between an AC plug point and a DC plug point. We actually put USB connector. So directly you can charge your cell phones and things like that. We designed a brushless DC fan, tube lights. We designed a remote. We are designing in 2014, 15. We might as well design. And at 20,000 rupees, I could actually change the whole one small homes. And we also designed a desert cooler. We purchased DC powered color TV. We did DC mixers, butter churner, atta chakki, sewing machines, and we started then putting it in a village. Everybody opposed it. The electricity department, I went, Piyush Goyal had become the Minister of Power. Fortunately, he was a friend. We together were working both on the board of State Bank of India, and I talked to him and he said, come and make a presentation for us. All his officers, all the MNRE, everybody was in the meeting. And they said, DC electricity, you are taking country backward. This has been solved 125 years back. We will not let you do that. And we argued and argued. Sure, by that time we had actually connected several homes, but they were adamant. Finally, Piyush Goyal intervened and said, okay, you know these deserts of Rajasthan, close to the border of Pakistan, you don't have any way to take a grid? They said, no. You have no plans to provide them electricity? No. He says, what if I ask Jhunjhunwala to provide electricity there. I said, I'll be very glad. They said,
Shall we take some questions, sir? So, shall we take some questions?
Can I just finish it fast?
Yeah. Okay.
So we actually went and put 4,000 homes and started moving very rapidly, and things started happening very, very rapidly after that. We then did 30,000 homes in Assam, and we went on doing more and more homes in deserts, in mountainous area, and we went to villages and all over. We have done 60,000 homes, and we have done this. Well, last few slides. If towards 100% renewable energy, what does India have to do? We have to expand renewable energy. Solar and wind could play an important role, but we probably need a third source. Can small nuclear plants play a role? Can India's ocean energy can play a role? Power distribution and transmission will need strengthening, because that's a critical thing. And we will need all kind of storage. Lithium-ion battery storage we are always doing. But I recently found out through a colleague of mine, to SIDDHI, that zinc metal and aluminum airflow batteries could play a very important role. So one has to work on that. Chilled water storage, hydrogen, pumped hydrogen. We need R&D on all these things. Going forward, India will need electric vehicles. I talked about it. We'll need hydrogen-powered electric vehicles. We need to improve the energy efficiency. Air conditioning energy efficiency will play a major role. We need to convert industry. And for that, we need hydrogen for high temperature industrial heating, and decarbonization, and heating by heat pumps. All this is what we will require. Our agriculture will require solar pumps and electric power tractors and machinery. Construction will require every machinery, petrol and diesel powered machinery, to be changed to electricity. And in policy, we need to intervene. This is what India will require, and we are very determined that we'll make a huge mark by carrying out all this R&D and commercializing things and deploying this over the next 10 years. Thank you very much. I'll stop sharing and then answer the questions. Should I take the questions directly?
I can read out a few questions, Ashok.
Okay, please do.
So one question is really asking how soon can this prototype be taken to market? And who can do the implementation at scale? If it's
we are doing IIT Madras Research Park. In 2 years' time, we will get the thing done, proof of concept, and after 2 years, we can take it to the market. Probably sooner, but we'll look at it. If there are people who are ready to join us and push us, we can do it faster.
Okay, so another person seems to have a personal interest in solar DC idea. He is asking, how do I do DC air conditioners and refrigerators?
Well, we have done some prototypes. We had kind of abandoned it because even though so all the tough areas, hills of Himalaya, hills of Assam, Jammu and Kashmir, in Ladakh, Arunachal Pradesh, Meghalaya, Manipur, we could go. But the power department, MNRE, are still too conservative. They didn't even approve the standardization of 48 volt. It is only now, 5 years later, Bureau of Industry Standard has done it. India's policies are very, very problematic. If we go full-fledged solar DC, we can still make a big change all over the country very quickly. We have done prototype of air conditioners, and other things can be done. But, well, that's what my answer is.
Okay. Another interesting question is that some of the European countries that are close to the pole are doing much better in terms of renewable energy. Is there some reason why they are doing it, and why are we lagging behind?
So, first of all, many of them also have hydropower. So they are mixing, and what they are doing also is that solar and wind generated all over Europe, they are transmitting now to each other. So what is happening as a result, they are getting much better balance of solar and wind. They need less storage. Plus they can afford more. They are now focusing on storage, and they are moving. their consumption is much higher. So they are moving much more rapidly. India just not begin. All these years, we have been saying, well, we are not the polluters, so we won't do it. It is only now it is hitting us hard.
Okay.
It's a will. It's a will.
Okay.
Remember, their interest cost is also low. Interest cost lower helps. I just showed you. Their costs are lower. They don't even have to innovate as much. We have to do far more innovation.
Another question which I think is interesting, which is there going to be a real impact on India's electrical energy needs due to the e-mobility, electric vehicles?
Yeah, so I just pointed out, our electric vehicles by 2030, significant part of our vehicles will be converted to electric. By 2035, I'll say almost all. All the new vehicles. Old vehicles may remain, but as they are phased out.
And that is I think the intent of the question is that going to be a very large electrical need, and can we actually do it? I think
no problem. In fact, today our energy consumption is only 60% of our capacity. So I don't think, and we can generate, solar and wind can be put very, very rapidly.
Okay.
I've taken the electric vehicle, I've taken all the energy to be electric when I said that 4% of Rajasthan desert can generate enough electricity for the whole country. We had done that computation while I was in Delhi.
So there are lots of other questions, but I think we are running out of time. So what we can do is we can kind of summarize these questions, Professor Ashok. At some point, we can also get answers to these, because many questions are very similar. I think the biggest concern seems to be, can we do it? Is the question.
We will do it. We have no choice. And I'll say we are determined to do it. Okay. This is one of the key tasks that the research park has taken up. In next 10 years, we'll make such significant impact with the help of Professor Raghu, Satya Shashadri, all others in the institute. We are going to do it. We will have enough work going on. If you are interested, contact me. I've just given my email address on chat box. Please relate it to everybody. ashok@tenet.res.in. Please send me a mail. I will answer each and every question. I can send you the PDF of the presentation if you ask. Plus, but you have to write to me a mail, and I will do that.
That's wonderful offer, Professor Ashok. Thank you so much for a very nice seminar. I request Karthik to say a few closing remarks. And thank you again, Professor Ashok.
Thank you.
Thanks a lot, Professor Ashok. It was a wonderful talk as usual, and I think very topical, as was yesterday's talk and as tomorrow's talk will be. And I think there's a huge amount of interest. There are close to 100 questions in the chat box, so we will summarize some of them for you and send it. And as you said, the participants can directly contact you as well. So thank you again. Thank you again for taking your time and passionately discussing this very burning problem that's ahead of us. And just a reminder to everyone, you can always view this recording and share it with your friends and colleagues via the SIDDHI YouTube channel and the IIT Madras YouTube channel. So this talk is available online already. It was streamed live there. There were a lot of participants watching it there. And you can share it with your colleagues. And tomorrow, I think everybody is excited to hear about 5G. And from our director, Professor Bhaskar Ramurthy. So he's going to talk to us tomorrow about India's 5G standard, the manufacturing ecosystem, and the impact it will have. And I think this is again a very exciting talk. So please do tune in for this tomorrow, same time, 6:30 p.m. And I look forward to seeing all of you there, and wishing you all a happy Independence Day tomorrow. And
happy Independence Day from my side. I want to again point out my email address, ashok@tenet.res.in. Write to me if you want the slides. And thank you very much. I'll disconnect at this point.
Thank you, sir. And I would like to just close thanking the SIDDHI team who've been instrumental in putting all of this together, and everyone else involved. Thank you all.
Thank you.